Usually this is how we take group photos now. Hopefully we'll be able to take the more traditional way when we're all together after this pandemic. So we're going to continue with our presentations now, and I'm happy to welcome our colleagues from the World Food Programme to talk to us a little bit about the hunger map. I believe Elisa is leading this. So over to you, Elisa.
Yes, thanks, Hassan. Okay, let me share my screen. All right. Can you see it well? Full screen mode?
Yes, yes.
Okay. Okay, thank you very much for the invitation. For WFP to join this workshop. I'm going to tell you a little bit about our platform, the Hunger Map Live, and about the predictive model that is fueling it. So the goal of the Hunger Map Live is to provide a platform to help assess, monitor, and predict hunger and specifically food security indicators sort of globally in close to real time. So how do we do that? Well, first of all, there's a data integration component. So one of the big efforts that we had to do was to integrate a variety of data sources. One of which is our near real-time monitoring systems. So as WFP, we conduct surveys on a daily basis, through remote phone calls, to obtain household information to compute our the indicators of interest for our food security analysis. But then on top of that, of course, we also had to integrate a lot of other contextual information about conflict, economics, climate, etc., that can give both contextual information for the people that go and look at the hunger map, but also that these are the components that fuel the predictive model. So the third component of the platform is this hunger predictions. Let me first clarify, like since the very beginning, that what I'm going to present is a model to nowcast food security indicators. So we are now working also on a forecasting model, so looking at how the situation is likely to evolve into the future, but that's still pretty much work in progress. What we have currently on the hunger map is a model that helps us nowcast the situation. So basically estimates what's currently the situation in all those places where we don't have near real-time data. And then fourthly, we have a data visualization component on the hunger map. Of course, like it's a public website. The first thing that you see is actually the visualization part. So these are, this is just to give a broad overview. Let me first, before I go into the model, let me tell you a little bit about our near real-time monitoring for food security. So this is both what you can see in the hunger map for over 30 countries, and also what is behind, like what is the ground truth data for our model. So this started back in 2018 for Yemen and Syria, then it was scaled to a few more countries in West Africa in 2019, but really it was last year because of COVID-19 that we have started to monitor the situation on a daily basis in now we're in over 30 countries. So basically on a daily basis, we perform these phone calls, phone surveys through call centers around the world that speak local languages, and of course we're not able to collect a given amount of data on a daily basis that is representative of every region, every province. But what we do is we have a rolling window approach. So on a daily basis we collect a given number of surveys, but then the representativity is along across like a 20-day, 30 days, or 3-month period. So every day we're able to give an estimate of the food security situation in an area by looking, by aggregating the data collected over the last 30 or 60 or 90 days, basically. So this data is collected on a daily basis through the call centers, upload on an API, and then automatically processed every night to then be displayed on the AgriMap. So this is the near real-time food security part. These are the countries that we are now covering according to that timeline that I briefly described. But then what do we do for all the other countries where we don't have this information? So of course, like we're now in this scale-up process where we cover more than 30 countries, but of course there's always places that we won't be able to cover at all times. So what we wanted to do was to get an estimate for areas and countries where we don't do this continuous data collection. So as I was mentioning in the beginning, to do that, first we had to consolidate a data lake where we collect population data, nightlight images, rainfall, vegetation data, conflict from ACLED, then things collected by WFP, such as market prices, then macroeconomic indicators, some also undernourishment data from FAO, and then finally, of course, as I was saying, like the ground truth for all of this is also the data itself on the indicators that we are trying to predict. So all the data that we are collecting from the continuous monitoring system, as well as all their data on face-to-face assessments and other remote surveys that were done in the past, even before these continuous monitoring systems were in place. And so when we started this effort, what we were able to collect in the first few months, even before the scale-up of the continuous monitoring system, was to get a set of historical food security data that is spanning almost 15 years and over 60 countries, like where WFP operates. So to go a little bit more into the details of the model, so first of all, what do we try to predict? So there are 2 indicators that we are mostly interested in. So it's the first one is about food consumption. So basically the prevalence and the number of people with insufficient food consumption. The way we compute this is through the food consumption score that we got from the household surveys, and then our prevalence of people with insufficient food consumption is given by the prevalence of households that have food consumption score classified as poor or borderline. So this is our first indicator and the one that we are mostly interested in. And the second one, also important, is the prevalence of people using crisis or above crisis food-based coping. So basically, this is based on the reduced coping strategy index. So another indicator on the coping strategies the household have to implement to cope with the food scarcity. So these are 2 indicators that I think most of you are familiar with, in the sense that they're also used in the for IPC, etc. So I don't think I need to go more in details, but if I do, let me know. And then we selected a list of independent variables to fuel the model, of predictors. So when it is available, we use the latest FCS or RCSI measurement, according to which indicator we want to predict. Then from ACLED, we look at the number of conflict-related fatalities in the area. Then we look at rainfall and vegetation from the satellite imagery. We look at cereal price variation as data collected by WFP itself in different, in markets around the world. Then in terms of economics, we look at how inflation changes. We look at the nightlight intensity as a proxy for like poverty and combine it with GDP. Then we also take into account the latest undernourishment estimate and some spatial temporal coordinates like latitude, longitude, and month. And all of this, we basically, for the way we train the model is to, like, for all the places and times for which we have an FC, like an FCS measurement, for example, we build a vector with all of these metrics. And the resolution is at admin1 level. Of course, like some of these data, they are not at admin1 level. They are like more national estimates, but then we just use the same value for all the admin1s within the same nation, basically. And then, yeah, the kind of model that we use, and this is, yeah, maybe of interest just for like more machine learning interested people. It's a state-of-the-art machine learning model called XGBoost. Basically, it's a technique based on gradient boosted decision tree ensembles. And what we did to validate the model, basically, here, I put some further details for technical people interested. But basically, what we do is that we train the model on a subset of the data, and then we see how well it performs on another subset that the model has not seen, and we repeat this a few times. Then we also basically take into account for errors in the estimate and giving a confidence interval. We actually used bootstrapping so that we not only give like 1 point estimate, but we can also give a confidence interval also, I don't know, if like prevalence of 30% of people are food insecure, plus or minus, I don't know, like 5 or 8%. And this metric, like the coefficient of determination and the mean absolute error, these are two metrics that you can use to evaluate the performance on a model. The metrics that you see here, they are obtained. These were calculated like in June last year. So basically, we launched the first version of the model in January last year when we launched the Younger Map. Then we redefined a bit the model in June with some of the new data that was coming in. And now we are working to release a new version of the model in the next few weeks, I would say, or maybe a month, I don't know. I'm not gonna, I can't say for sure, but really now what we're trying to do is to integrate a lot of all the data that has been collected during the last year. So we're also hoping to actually have these numbers improved. And here you see there's like 4 different models, because there's one model for the food consumption, one for the, well, 2 models for the food consumption, 2 for the reduced coping strategy index, because in both cases, we have a model that also has as input variable the latest available estimate of that indicator available for that given area. And of course, when that's the case, the accuracy of the model is higher because you have a baseline to start with, and then a version where you don't have this, we don't take into account this. So this kind of model is to be applied when for areas where we really have no other, like no previous measurements, and this happens for both indicators. So what are the next steps? As I was saying, I integrate the new data from the continuous monitoring systems. We are also exploring new predictors, or like refine the ones that we already had. Like, for example, just to give an example, like ACLED, like the conflict variables. At first, we were just looking like at the number of fatalities in a given area. Now we're looking like at different we're trying to figure out what's the variable the best that is a best predictor for food insecurity. So like looking at change over time, or like looking only at certain class of events, etc. And then another big priority right now for this year is also to improve the explainability of the model. So right now it's really more of a black box. Of course, like we have all these input variables, but then from those we really show an estimate, and really what our country offices and regional bureaus and users want to see is also to try to understand like how did you obtain that estimate. So what you know, like, so we need to show them, okay, how did the variables change over time? So why am I seeing a predicted increase? Well, that's because, for example, inflation has gotten worse, or, you know, or like there's a drought or something like that. So this is something we're trying now to, we're working to integrate into the UngerMap, so some sort of explainability of the model. And then we're also working on a peer review paper to give it also a more scientific validity. Then what are the main challenges that we were facing while building this? Well, as I was saying, we needed to put together data from different sources. So first of all, at first we had little and non-standardized data mostly for the food security indicators themselves. So the indicators that we were trying to predict. Right now, with the continuous monitoring systems, we have you know, like a standardized way to process the data, store them, etc. in our DB, so that's easy to use. But at the beginning, what we did was also to basically extract from a lot of reports, etc., data about face-to-face surveys and previous assessments that were conducted. So that was a big effort that we did at the very beginning to add the data to train the model on. Then also the other challenge was to find covariates, like the input variables, to find data sources that would have a global coverage, and also that is regularly updated, that has a good time resolution, etc. So it's not only about finding data, but making sure also this data is actually provided in time, so that our system, like the UngerMap, every night queries all the different APIs and DBs that we are looking for, but like our model doesn't work if there's no new data coming in. Then, of course, like the other challenge, not from the predictive side of things, but in general, like to maintain the system, was to scale these monitoring systems to, I meant to 30 plus countries, but we do have a goal of 60 countries by the end of the year, which of course is going to be a challenge. It's a lot of time, resources, etc. But it's data that WFP clearly needs and relies on. So that's what we are working on towards as well. And then, of course, maintenance of the infrastructure to ensure near real-time information. So if the model is to like run every night, and if all these continuous monitoring system are to provide data every night, of course, there's we have a full team of software engineers as well that make sure that the infrastructure works and is stable. So all of this that I told you then goes into this platform that is openly accessible, hungermap.wft.org. It's meant to be a digital public good, so you can all access it. And then basically you whenever you click on a country, for example here, put a screenshot of for example Sudan. That's one of the countries where we do predictions. Like you can see on the side a lot of contextual information, and then when you click on an area, you get the estimate of people with insufficient food consumption, that as it comes from the model. For example, in this area, we only predict food consumption. We don't predict crisis like RCSI, just because we only do that for a few countries where there's enough information and training data. And and so there's two kind of countries that you can click on, like for the 30 countries where we do the continuous monitoring, then you will see here on the left in the food security trends, you will see the trends that come from these daily surveys. And for these other countries like Sudan, where we instead do prediction, you will see the results of the estimates from the machine learning model they just presented. And then on top of the UngerMap, we also have a suite of products that we are now providing to our country offices and partners. So for example, for the countries where we do the continuous monitoring, every week we publish these hunger and COVID-19 snapshot, where we show, as the name says, a snapshot of the situation in terms of food security, but also other things that we ask in our surveys, such as health access or market access, RCSI, but also livelihood coping, etc. And that's it for now. Thank you. And yeah, over to your questions.
Great. Thank you very much, Elisa, for that presentation. So I'm going to open the floor for questions. Oh, great. We have a number of questions. So we'll start with Lucas.
Hi, hello. So this is Lucas with the REACH initiative. Thank you so much for the presentation. It was obviously excellent, and the work behind it is very, very impressive. So I have two questions. The first one would be on your next steps. You mentioned that one of the things you'd like to try is explore some new predictors, some new independent variables. But when I was looking at the list of independent variables that already go into the model, my very uninformed impression is that perhaps quite a lot of them seem to be quite likely to be highly correlated with one another. So I was wondering, how do you decide on keeping all of those predictors that you already do have as model inputs? And the second question I have is, if I understood correctly, you have been running the model for quite a while already, perhaps as much as a year now. So I'm wondering if the results that have come out of it 12 months ago, I would guess that you made a 12-month prediction when you started it in January last year. So how good were the results, basically? Not just when you split your input data into a test and validation data sets, but how are the results actually borne out by the reality? Thank you.
No problem. Do I reply now? Do we want to collect the different questions?
Yes, please, you can reply.
Okay, cool. Yeah, so regarding your first question on the variables, well, what we have now, like more than adding new variables, like you're right, we already cover most of the dimensions that are of interest, like the main determinants of food security, so like climate, conflict, macroeconomic shocks, etc. So more than really like adding new variables in the sense of new predictors, what we're trying to do is to better define the variables as they are now. So like the example that I was doing on conflict, like what we have all this conflict data, but what's the best, like the variable that is most highly correlated with food consumption score. So in this effort, we're also like exploring, of course, like correlations among the different variables that we have. So this is something that we're taking into account. At the same time, the model that we use is not like a linear regression, so it's not as fundamental to have uncorrelated variables, right? So like there's not like collinearity issues are less of a problem in random, like in regression trees, etc. So you can also have non-linear interplay between the different variables, but of course, like we try not to have something that is super correlated between each other, of course, because that would be redundant. But yeah, so let's say that the first approach was to, like we try to build variables that made the most sense, but now we're doing a more let's say systematic approach where we really for each let's say for each area of macro area like conflict, economics, etc. We try to build a bunch of variables, and then first we look at the correlations among them. Then we see the correlations from like of each of these variables with the food consumption score, and then we only take like the ones that are the highest correlate, and we try them in the model, etc. So this is still work in progress, but that's a little bit the approach that we're taking. And regarding your second question, that's also something that we'll look into, in the sense that like indeed last year we started making predictions also for some of the countries where at some point we started doing the continuous monitoring. So now we do have ways of comparing how things are going. We haven't done it systematically yet, but yeah, it's in our definitely in our to-do list. Thank you for your questions.
Thank you. So Jana.
Yes, hi, Elisa, sorry. Thank you for this presentation. It was very useful for people who are trying to understand how the maps are being developed and what is the existing source of data. So one of the questions that I'm interested in is, what is the source of data that you mostly rely on for undernutrition?
Yes, so for undernourishment, we use the data from FAO-Stat, so the prevalence of undernourishment. So that's yeah, that's the variable that we use. And then for the food security indicators is the the indicators that we collect as WFP.
Can you mention the source again for?
Yeah, FAO-Stat.
Okay, thank you.
We have a question from Kutab.
Yeah, thank you very much, Hassan. Elisa, this was a wonderful presentation, was really helpful. Actually, when we was looking to it, I think my colleague who is here will also have the same kind of questions, and I think a part was also asked by other participant. Variable selection, the predictor selection, for us, we were also doing the same kind of project for South Sudan, and we were really like was in trouble because we had more than 132 variable, and we try our best to minimize the predictors, and we able to reach 40, but it took a lot of our work. So my question is, the first one, how come you agree on those variables and those predictors? The second question about the one you use, the model, XGBoost model. Did you compare this one, the performance of this model, with other models? And if, because for me, this is very new, I never used this one. So I just want to learn that how was its performance against other models? Thank you very much. Over to you.
Yeah, thanks, Kutab. Yeah, for the variable selection, I mean, what we're doing is to build as many variables as possible. And now we are basically then, the approach we're doing is like train the model with all the variables, then remove the least significant one, retrain, etc., and see until like as we remove variables until the model performance doesn't really significantly change. So the approach is, okay, let's have as many variables as possible at first, but then let's try to get rid of them so that we don't risk too much overfitting, or like we want to try and have the simplest possible model, but that also maximizes performance and covers different aspects. So the way we decided to include the different variables was from like expert opinion, no? So basically we looked at what are the factors that experts think affect food security, and then built variables based on data sources that would represent those factors that have been identified. And then, yeah, now we're using a more like, after we've built all of this, now we're using an approach where then it's the model itself that tells us what are the important variables and which ones are not. In terms of different models, I have to say we haven't tried many other approaches for one main reason. So our model being like, so we're trying to make predictions for many different areas, and as like, even though we, of course, like the kind of data that we pull in and we use to define our input variables. I mean, as I was saying, like the challenge is to find data that is available for all places at all times. So this is not always the case. Like some of our input variables, in some specific cases, we don't have it for a given area or a given point in time, etc. So the power of XGBoost is that it allows to include in the model also some null values. And so the model is relatively robust to the fact that even if you don't have one variable for one of your observations, it can still produce an estimate. So this was a key element for our model, because otherwise, if we wanted to run on a daily basis for all places at all times, of course, we need to have this feature in the model that even if sometimes some little element is missing, at least it doesn't break, let's say, and it's still able to make an estimate based on the other available values.
All right, thank you very much. And just, Elisa, there's a question on the chat box from Said Rahman, and he's asking, do you apply the same model across countries you're predicting countries in? How do you account for potentially different effects of predictors in different contexts?
Yeah, so right now we applied the same model. Actually, the model is built using data from all the different countries, as if we don't distinguish. Of course, there's some variables that characterize also the country that you're in. So, for example, some macroeconomic indicators that are, or the undernourishment estimates, for example, they are the same for all the admin ones in the same country. Yeah, I mean, of course, we are aware that there are local contexts. At some point, ideally, you would like to have enough data for each country to be able to build a model that is country specific, but that is not the case yet. I mean, so this is this was the only possible approach that we had, was to build a model that would put together different areas from different countries. Because I mean, for some countries we maybe have, I don't know, just a few tens of observations, and you can't really train a model with such few data points.
Great, thank you very much for that. So we will now move to the next session or the next presentation by our colleagues from Action Against Hunger. They will present the model